Welcome to this lesson on the scientific method in chemistry. The scientific method is the foundation of all chemical research and discovery. It's a systematic process that chemists use to explore the properties of matter, understand chemical reactions, and develop new materials. In this video, we'll explore how scientists move from initial observations all the way to well-established theories. The scientific method is a systematic approach to understanding the natural world. It relies on three key components: observation, experimentation, and logical reasoning. By carefully observing phenomena, designing controlled experiments, and thinking critically about results, chemists can uncover the laws that govern how matter behaves. This method ensures that scientific knowledge is built on evidence rather than speculation. The scientific method follows a series of structured steps. First, scientists make observations about the world around them. These observations lead to questions about why something happens or how it works. Next, they form a hypothesis, which is an educated guess that can be tested. Finally, they conduct experiments to test whether their hypothesis is correct. Let's look at the remaining steps. After conducting experiments, scientists analyze the data they've collected to look for patterns and relationships. Based on this analysis, they draw conclusions about whether their hypothesis was supported or not. They then communicate their results to the scientific community through publications and presentations. The final step is to repeat and refine the process because science is iterative. New experiments often lead to new questions and deeper understanding. A hypothesis is a testable prediction or educated guess based on observations. It's written in a way that can be tested through experimentation. For example, if you observe that salt is often used on icy roads, you might form the hypothesis: if I add salt to water, then the boiling point will increase. This statement is specific, testable, and based on prior knowledge about how substances interact. Testing a hypothesis requires careful experimentation. Scientists design controlled tests to gather evidence that either supports or refutes their prediction. They collect data by measuring and recording observations during the experiment. Repetition is crucial. Multiple trials ensure that results are reliable and not due to chance. Scientists also control variables, meaning they keep certain conditions constant while changing only one factor at a time. This helps isolate the specific effect they're studying. A hypothesis is just the beginning of scientific understanding. When a hypothesis is tested repeatedly with consistent results, it can evolve into something more substantial. As multiple experiments by different scientists confirm the same findings, the scientific community begins to develop a broader explanation. This well-supported explanation becomes a scientific theory. Unlike a hypothesis, which addresses one specific scenario, a theory explains a wide range of natural phenomena based on extensive evidence. A scientific theory is a comprehensive explanation of natural phenomena that is supported by extensive evidence and repeated testing. Theories are not just guesses. They represent the highest level of scientific understanding. A good theory has three important characteristics. It is well tested through numerous experiments. It is widely accepted by the scientific community. And it is predictive, meaning it can be used to make accurate predictions about future observations. Examples in chemistry include atomic theory and the theory of chemical bonding.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.